This is problem 10 in chapter 6, in which there's a fairground ride that spins the riders in a falling saucer-shaped container, so like a big merry-go-round. The horizontal circular path the riders follow has an 8-meter radius. How many revolutions per minute will the riders be subjected to if they have a centripetal acceleration whose magnitude is 1.5 times that of gravity? So in this case, you're spinning so fast that you actually get pushed outwards more than your weight. So it would be a very, very strong ride. So the acceleration centripetally is equal to the radius times r times the angular velocity squared. And what we're asked to find is essentially the angular velocity. Now this is in radians per second, but we'll have to convert that to revolutions per minute. So I solve for the angular velocity by dividing by r, flipping the equation, and doing the square root. Okay. And what do we know? I don't have a value for the centripetal acceleration, but I know it's 1.5 times gravity. So this is 1.5 times 9.8 meters per second squared. All of that divided by 8 meters. And then you take the square root of that. And that equals 1.36 radians per second. Please note that the meters cancel, so you're left with just 1 over s squared inside the square root sign. Radians are actually unitless, so they just kind of come and go, which is very annoying to students. But since this is an equation for the angular acceleration, we know that the units are radians per second. Now, how would I convert that to revolutions per minute? I have to get rid of radians, and we know that 1 revolution is 2 pi radians. So that gets rid of those. And I know that in 1 minute there are 60 seconds. So that gets rid of seconds. And I'll be left with revolutions per minute. And it turns out that that equals 12.9 revolutions per minute, RP.